So hello friends, in this particular video, we will discuss a very interesting but a little bit sad kind of problem. This problem is directly related to kinematics. Let us see what all values are given in the problem, what is the condition which is given in the problem. So in this very interesting problem, we have a passenger who has just missed the train. So we have a very sad situation over here that the passenger who was supposed to board the train has unfortunately missed the train. And now, left with no other option, he stands on the platform, sadly watching the last two bogies of the train. As the train is departing in front of his eyes, he is observing the last two bogies of the train. The second last bogie takes 3 seconds to pass by the passenger, while the last one takes only 2 seconds to pass him. Now we have to find how late the passenger is for the departure of the train, and in this particular problem, we have to assume that the train accelerates at a constant rate. So let us start the problem by making the assumption that the passenger is late by t seconds. So let us assume that t seconds is the time. Let us assume that the passenger is late by t seconds. And accordingly, we have to find the value of this time only. Because ultimately, that's what we are supposed to find, that how late the person was for the departure of the train. So now if the person is late for the departure by t seconds, we can say that the train was already in motion for t seconds. So now for the motion of train, I can write the expression as, since the train always starts from rest, so I can write initial velocity of the train will be 0, and assuming constant acceleration of train to be equal to a, since the train is already in motion for t seconds, let us find the velocity of the train at an instant when the passenger just arrives at the platform. So with the help of first equation, I can directly write v equals to u plus at. Now let us shift our entire focus to the second last bogie. As soon as the observer starts or the passenger starts observing the second last bogie, he is going to see the speed of the second last bogie as at, the value which we have already found. He will observe that the second last bogie in front of him has an initial speed of 80, and since acceleration of the train is assumed to be a, it is also mentioned that the second last bogie takes a time of 3 seconds to cross the observer or pass the observer. So for the second last bogie, I am writing time as 3 seconds, and assuming the length of the bogie to be equal to L, I can apply the equation number 2 for this particular set of data. So I can write L equals to U T plus half A T square. Let us mark this as equation 1. Now instead of just observing the last bogie, I am considering the last two bogies as a single entity. So for the last two bogies, if I am considering them as a single entity, again I can write the initial speed to be equal to at, acceleration will be equal to a, and the total time will be equal to 5 seconds. 3 plus 2, 5 seconds for the last two bogies combined together, and the total distance that needs to be traveled by these two bogies will be equal to 2L. So this will make our calculation or problem part a little bit easier. Rather than just observing the last bogie, we are now observing the last two bogies combined. Again, we can apply second equation for this particular data set. I can write 2L is equals to U T plus half A T square. Now from equation number 1 and equation number 2, I can simply write it as, I am eliminating the value of L, so I can simply write it as 2 times of equation 1 is equal to equation 2. Now from here, the value of A will cancel out and the value of T on solving comes out to be 7 by 2 seconds. That is, we can say that the person was late by 3.5 seconds for the departure of the train. This is our final desired result.